Hi, I'm Dr. Pariser, and now what I want to do is talk about the forces in a hydrogen atom. The proton has a mass and the electron has a mass, and so there's a gravitational force between these masses. So the force of gravity between the masses is G times the mass of the proton, mass of the electron, over r squared. And the Coulomb force is K, Q1, Q proton, Q electron, over r squared. Now both of these forces are forces that fall off as the square of the distance. And it's hard to understand just from the numbers that are on the board which of these forces would be bigger. So what I'm going to propose is that we evaluate it. We see, is the gravitational force the biggest force in the hydrogen atom, or is the electric force the biggest force? And if we divided these forces, then how would you do this? If you make the denominator equal to 1 by multiplying by the reciprocal, then you have to do the same thing here. So what happens in the denominator? This goes out, and this goes out. And so what you have is K, Q1, Q proton, Q electron, over G, mass proton, mass electron. And now what I'm going to do is evaluate it. K is 9 times 10 to the 9th Newton meter squared per Coulomb squared. And these charges have the same charge, 1.602 times 10 to the minus 19 coulombs, and that's squared. G is 6.67 times 10 to the minus 20, that's 10 to the minus 11 Newton meter squared per kilogram squared. And the mass of the proton is 1.67 times 10 to the minus 27 kilograms. And the mass of the electron, 9.11 times 10 to the minus 31 kilograms. So what is all of this equal to? And if you take your calculator and do it with me, you have 9 exponent 9 times 1.602 exponent 19 with a minus sign squared, divided by parenthesis 6.67 exponent 11 with a minus sign, times 1.67 exponent 27 with a minus sign, times 9.11 exponent 31 with a minus sign. And so what you get is 2.28 times 10 to the 39th. The electric force in the hydrogen atom is much, 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 much bigger than the gravitational force. In physics 1, when you talk about throwing a baseball across the room, you look at the effect of gravity. In physics 2, when you talk about an electron moving through a cathode ray tube, gravity has nothing to do with the problem. This electric force is much greater than the gravitational force. So I'd like to sum up by saying, on Earth, the electric and magnetic forces are bigger than the gravitational forces. But what happens up in space? Up in space, you don't have isolated charges. But the major forces moving the planets around are the gravitational forces. However, in the hydrogen atom, the electric force, the Coulomb force, is much greater than the gravitational force. Thank you very much.